Welcome to Vertical City. I'm your host, Lennon Richardson. During each episode, I interview one of the world's top experts in architecture, urban design, engineering, or ecology so that we can better understand and develop solutions for sustainable living. Thank you for listening, and get ready to join us on another groundbreaking and uplifting episode. Scott Ceasar is one of the world's foremost authorities on sustainable building design and is one of the founding members of LEED, Leadership in Energy and Environmental Design. Scott is employed by Cosentini Associates, a leading building systems consulting engineering firm, and has been there for nearly 20 years now. He operates as Senior Vice President and Director of Sustainable Design. In addition, Scott developed and now oversees their Advanced Technology and Analysis Group. In this interview, we discuss the ever-evolving definition of sustainability, LEED certifications, passive house systems, net zero, and how all of these concepts apply to Scott's work and the prospect of building the world's first vertical city. I'm conducting this interview remotely from Portland, Oregon, and Scott is joining us from his office in New York City. Show notes and links to everything discussed in this interview can be found by visiting verticalcity.org/podcast. Scott, well, I'm excited to have you on the Vertical City podcast. Thank you for being here.
Thank you, Lennon. Thanks for having me.
Great, I appreciate it. I wanted to start just by asking you, how do you define sustainability? I'm asking this because so many people have so many different definitions, and I'd like to see what yours is.
And it's actually a very good question because there are a lot of different definitions of sustainability out there. But my definition is it comes from the word sustainable. You're building a building that's going to last for the future.
Okay.
And that's going to be good for the future. Let me just expand for a second, just because, again, I always hear people talk about sustainability as we're going to put some renewables on a building, or we're going to build an energy-efficient building, or a materials-efficient building. And really, it's all of those, but in the end, you're trying to build a building that's good for the future of the building and for the future of the world around it.
Yeah, that makes sense to me. So it kind of sounds like one of the approaches that people will take is that they're kind of thinking of sustainability as an afterthought. How do we wrap sustainability onto this thing? Maybe it's a building or whatever it is. But your approach is more of this integrated approach where you're thinking about sustainability before anything is built. Is that correct?
That's correct. At the very beginning, you start to think about what you want the building to do, how it's going to fulfill its purpose. And then from there, you start looking at, always with the building being functional and doing what it's supposed to do, you start thinking about things like energy efficiency, materials and resource conservation, and really occupant comfort, occupant health and well-being, because if you have happy, healthy occupants, the building functions better. And if you're looking at something in terms of an office building, your employee productivity goes up, and the building is actually performing better and making more of a return on investment for the building owner.
Great. I'm glad you brought up the idea of occupant comfort, and that's something I was actually going to ask you about a little bit later, but I'll just do it now. Is that becoming more of a focus when it comes to selling sustainable technology?
That's for a lot of major corporations have really started to look at this and starting to think about things like employee retention and keep getting the best talent they could. And by having a space that encourages well-being of the occupants, it helps to keep employees and helps to make them more productive. So, and that's one of the things we've seen change a lot in the last 20 years since I've been doing this. Okay,
excellent. Because it seems like previously the major focus was all on energy savings. And another question I have is, since energy prices are down right now, has that at all affected your ability to position or sell sustainable technology?
So at this point, I haven't really seen it affect anything. Yet the people who really want to do sustainability, it's still a high priority.
Okay.
And the developers or people who just wanted to build sort of a basic code compliant building, they're still sort of doing what they've been doing.
Okay. How much has that changed over the last 20 years since you really became involved in sustainability?
So that's one of my favorite questions, because I've just seen such a change in the whole industry. One of the big things is when this first started, my first job, my first sustainable project was working on the 4 Times Square project for the Durst organization. And that was an incredible, at the time, attempt at sustainability because nobody had ever looked at a speculative office building before and said, how can we make this more sustainable? How can we make this good for the environment, good for the occupants? And what happened then is we designed a building and we started thinking about what can go into the building, some of which worked out really well and some of which it was, let's try this technology.
Okay.
Yeah, certain things, like for instance, we wanted to get photovoltaics on the building, and we wanted them to be very visible because it was more of a market transformation tool. So we have photovoltaics installed on the vertical surfaces there so that you can see them. You can see them from the street. It's not the most efficient use of photovoltaics. So I would say, since you're not maximizing your power production and not maximizing your return on investment, on the sustainability scale, it doesn't reach the peak. But again, it was a little bit of that was about market transformation. And as this started to develop and the Durst organization approached this really well. But when it started catching on a little bit, other people said, what can I put on my building to make it sustainable? So they have a building that was already designed or that they had in mind what they wanted to do and said, let's throw some photovoltaics or let's see if we can put a more efficient chiller in. And it was done sort of piecemeal. It was very much, let's take the newest technology and apply it to the building. But on a lot of jobs, other than the Durst job was different, but on a lot of the other jobs, there wasn't a lot of thought put to it. And now what's happened is we realize, and one of the things, just to go off on a tangent, one of the things I realized when I started doing this is sustainability was really a new term for something we'd been doing all along, especially on the energy side, which is really designing the right building, doing the right things for that building to make it more efficient. And so the big change has been in the sustainability world that people now look at sustainability as the most important thing is an integrated design process, getting all the systems in a building designed to work together and to make sense and to be the right thing for that particular building. I mean, a really great example, and one of the first ones that I really had the opportunity to do this on was a building that we did for a company in Canna up in Calgary, their new headquarters. And Foster & Partners was the architect on it. And they gave us an opportunity to do something that a lot of architects wouldn't have let us do before. They let us actually help them through energy analysis to mass the building and site the building to make it as efficient as possible. So we took 8 or 9 different shapes that they were looking at, and we ran them through an energy analysis, ran them through the points of the compass, spun them around. And doing these studies and working with the architect, together we came up with this big idea, which was the climate up in Calgary was very cold but had really high solar radiance. And the sun was very strong there, and the big idea became, what if we had this south-facing atrium on the building and we used it to collect heat, do some passive solar heating? In the summer, we also took that atrium and we used it as a buffer zone to absorb some of the heat. So we set up the building in groups of atriums. The sun would, in the winter, the sun would come into the atrium, would heat up the space. We let it, and again, just using passive natural effects, let the heat come up to the top of the space. We'd collect it, and we'd use that air to preheat the outside air coming into the building.
Okay, that makes a lot of sense.
So it was one of these things where by really looking at all of the natural effects, the weather effects in the area, we were able to get this extremely efficient building.
That sounds great. So you mentioned that this was sort of like an anomaly, that most clients aren't really doing this, letting you work with the different shapes. And I'm curious why that isn't, or if you have a sort of a thought behind why more people don't take that approach.
I think that, again, one of the nice things was a lot of my work is done in major cities where there's a lot of zoning restrictions and you don't have that type of flexibility.
Okay.
But I also think nobody had thought much about it. The process was always the architect designs the buildings and then we put our systems into the building. Where here we start thinking about up front, what's the right system for the building, and how does it work with the architecture and the structure? For instance, on that building, we did an underfloor air, which required a little bit different stacking of the heights of the floors, and that had to be done up front. We had to think about what system it was going to be that was going to work best with what the client wanted to accomplish, and get all that taken care of up front instead of just doing this sort of standard design on a building.
So it sounds like you were really leading that project instead of the architects leading it and saying, make the systems work.
Now, I don't want to say that we were leading the project. I want to say that it was done as a team approach, hand in hand.
That's awesome.
Where we worked together. Again, this was a very forward-thinking idea for the time that Foster came up with. And we've done this on some other buildings since then. We had a tower in Oklahoma that we did where Picard Chilton was the architect, and we went through the same process where we ran 6 or 7 different shapes through an energy analysis. We spun the building around. And what's interesting is we also looked at what the functionality of the building was. One of the big issues for this company, it was an energy company, Devon Energy. They wanted to maximize their amount of window offices and corner offices because they needed that for employee retention.
Okay.
And so we came up with a shape that was both energy efficient and maximized the amount of windows. So again, using sort of an integrated process, we came up with the best possible building for its function that we can get.
Makes sense. So it sounds like at some points in time there's a bit of a conflict between occupant comforts and sustainability and then also aesthetics. And is this a battle you're often coming up against?
Sometimes aesthetics becomes a battle. Occupant comfort and sustainability, to me, I try and look at them together, but there's things that are always at odds. For instance, increasing the amount of outside air into a building, it gives better, in a lot of instances, it gives better air quality, but it also increases the energy consumption of a building. Yeah. So we look for other ways to do this. For instance, we look at some high-tech filtration. There's a system that we're looking at that uses ionization of the air and gets all of the dust particles in the air to clump together and get pulled out by a filter.
That's neat.
So the idea is now we can get better air quality without putting in a lot of additional outside air without increasing the energy consumption in a building.
All right. So you helped start the whole LEED movement 20 years ago, and I know that it's done a lot of good for the world, but I've also heard some criticism levied against it, but I just wanted to hear your take on LEED as it currently stands, and how important is it these days?
At the time, I think it was an incredible thing because you needed something to get people to start paying attention to this and start thinking about how they do their buildings. It's the whole thing where you have, basically some sort of pioneers who try something out at the beginning, then you get the early adopter phase, and then it becomes a little bit more standard.
Yeah.
So I think LEEDs run through that. At the beginning, there was so I was on the original committee that was developing LEED with the U.S. Green Building Council. And one of the things that I found most interesting in the arguments that were going on was where to set the bar. And there were people who said if you don't set the bar high enough, it's not really sustainable. And then there were other people saying you have to start someplace or you're not going to get, especially we're talking about the real estate development industry. You need to start slow and get people to start doing things to transform the industry. And that's how the whole the LEED tiers came about, where you have the certified and silver, gold, and platinum. It was to have different levels to have people make different reaches.
I see.
And it took a while, but LEED hit the point where it had become, for major buildings, the industry standard, to the point where lenders, if somebody was going out and trying to finance a new building project, lenders were saying, you need to get this LEED certified.
Is that still the case?
Requiring it. I'm seeing it less and less now. But I think what's happened is I think it's done its job in a lot of cases where people now understand LEED and people understand sustainability, and a lot of clients now are just doing sustainable buildings without going through the certification process.
Mm-hmm.
A few of the criticisms that are out there is the whole LEED process has become more of a business.
Okay.
And taken on a life of its own, Which I just think that's the fact is it's grown so big that USGBC really couldn't handle all the certification work, and it had to start becoming its own entity.
Mm-hmm.
And so they established the Green Building Certification Institute and sort of spun that off onto its own. It's still related, but it's become a professional organization with lots of people who review projects and go through and certify them. The other thing that I'm seeing is LEED has certain things that haven't made as much sense. They were great at the time, but now maybe it's time for it to upgrade. And LEED version 4 that's out now does a lot of that, where it's gone more on life cycle of materials and health and wellness of materials as opposed to some easier things to meet. And it's really been transformed. Before, for sustainability, it was recycled content. Where does it come from? How far did it travel? Now what they do is they rate your products based on things like embodied energy, what it takes to produce it, what are its components, how healthy is the product. And that's become some of the new credits, and new certifications have come around materials for that. And it's starting to transform the industry. I think one of the reasons it took so long to get version 4 released was because the building industry wasn't really ready for it. The products didn't have the certifications required, and so we've seen a lot of manufacturers pick up these certifications.
Oh, okay.
So the other thing is a lot of developers have gotten to the point where they sort of understand the process, and they feel they don't need to pay the money for certification anymore. They can just design a sustainable building.
Yeah. It makes me wonder how much of it is a marketing effort these days and how much of it is the other factors that tie into sustainability, occupant comfort and lower energy costs. Are clients wanting to do LEED still today as a way of saying, hey, we've got a LEED green building?
I think in some markets, yes. I think in the commercial office building market, we're still seeing tenants are coming and asking for a LEED certified building because it's a way of really knowing that somebody's looked at the building and somebody said this really is a sustainable building. Yeah, some of the high-end luxury condos, we're not seeing that being very important anymore. Some residential projects, again, not that important. But I'm seeing a lot of the rental residential, the high-rise rental projects we're doing still going for LEED certification. And I think the reason they're doing that is they're marketing the health and wellness side of LEED, where they're saying, indoor air quality is important. Materials that don't off-gas are important because we can sell that to our tenants. We can help market the building with that.
Yeah, it is. I really like that approach. Another idea that's come out of that I've heard is what happens if power goes out? If you have a really well-designed building, then you would be comfortable, even 24 or 48 hours, even if you weren't in the best climate.
Well, we've again sort of had that. A big transformation in New York was after Sandy, resiliency became very important.
Mm-hmm.
So certain things that we were doing for energy before, having a very well-insulated building, following something like passive house standards, becomes more important. Now, if you don't have power, you're able to remain comfortable for a longer period of time. But the other thing, for instance, we were looking constantly at putting small combined heat and power plants, cogeneration plants into the building and doing some distributed generation, recovering the heat and using that heat for the building. Now you can market to your tenants that if you have an extended power outage like we had during Sandy for a week, we're still going to have some, for instance, in a residential building, we're going to have basic power to provide things like one elevator is going to work. You're going to have in a high-rise, the domestic water pumps will work. You'll be able to flush your toilets. We'll be able to provide some level of heat into the building. And so that's become a big sell for a lot of people, that resiliency. And at the same time, we're saving energy.
Yeah.
Saving energy and reducing greenhouse gases because we have a very clean, high-efficiency gas microturbine or gas microturbines creating the power and the heat.
I'm sold. So you touched on passive house, and I'm curious, I want to learn more about this, and I want to know how much of an overlay there is between LEED and passive house. Is LEED embodying many of the passive house concepts?
So passive house almost takes it a step further. The idea behind it all applies to LEED and it all helps with LEED, but passive house spells out how to create this extremely efficient building, looking at how do we reduce our cooling and heating loads and usage by creating the right building.
Mm-hmm.
So it's about sealing the building properly, insulating it properly, trying to encourage things like passive solar heating, passive cooling by using things like night purge and thermal mass in a building. So really looking at your architecture and structure, and it goes back to what I've been talking about with integrated design.
Mm-hmm.
It's looking at the building with how it affects the mechanical systems and the occupant comfort.
What's night purge?
Oh, night purge is so when you have the proper environment, the building, for instance, an office building will cool down at night.
Mm-hmm.
When the atmosphere gets cooler, we actually run air through the building and let the structure basically heat the air and cool the structure down. We use this cooler air to absorb the heat that's embodied in the building, cool the building down, and it works really well if you have a high thermal mass building that holds on to this. And it's almost like a cooling storage. It's like a battery for cooling.
Oh, okay. So
we cool down the structure, and then we let that absorb the heat as people start working during the day in the building.
That makes sense. So this would be used in tropical environments and also during the summer in most places.
It could be used. Tropical might be tough because humidity is a problem.
Oh, okay.
So it works really well in places that are dry, but there's enough days somewhere like the New York area where in the shoulder seasons you can do a lot of that. In a really dry climate, if you're somewhere like Arizona or Utah where it's deserty, where at night you get that radiant cooling effect and the temperature drops a lot, it's very efficient there.
So if there was a building, like say it's a large skyscraper, maybe it's 80 or 100 stories, and it has a lot of thermal mass and it's very well designed and insulated, how much temperature would it retain? This can be approximate, obviously, if nothing was pumped into it, no energy was used in the building over a 24 or 48-hour period?
Depending, it's just hard to say. That's a hard one to peg because there's so many factors that go into it. But you can probably, for at least 24 hours, keep the building where somebody can stay if you really design it right, where somebody can stay in the building. Of course, even increasing the insulation and sealing the building, eventually you start the heating, the outdoor environment starts to take effect, and so it wouldn't be for a very long period of time, but 24 to 48 hours, you should be able to maintain comfort conditions in a really well-designed building.
Okay, that's pretty interesting. How much has this idea of passive house become integrated into large buildings?
We're just starting to see people look at that now.
Okay.
And one of the things that's very difficult with a large building, so there's one of the things very difficult with a large building is you have stack effect that you have to deal with, which is the change in pressure as you go up and down the building.
Okay.
Causes air movement, and if you get whatever infiltration, whatever openings are in the building, will allow air to come in or to exit the building. So in the winter, the big problem is the movement of the air is up, so you're always down at the bottom of your building sucking cold air into your building. So the more we can create very tight vestibules and seal the building, the less of that you get. And that's that infiltration is one of the things that's a pretty good percentage of the heating and cooling load if you don't design a building properly. Now, when you look at a sustainable building, that has one detriment, though. The more you seal a building, the less air exchange you get in a building, so the more you have to figure out a way to deal with taking out contaminants in the air. So you rely more on mechanical ventilation systems for that, as opposed to an older building that would have an older leaky building would have a way for contaminants to easily exit the building.
I definitely can understand that. It's funny, this morning as I woke up, as I walked into my office, I'm like, oh, the room is a little stale in here, and I want to open the window to get some fresh air in here. But if I do that, I'm going to lose this heat that's already in here, and I'm going to have to get the heater turned on. So it's the same battle, but obviously the one you're dealing with is on a much larger scale.
Right, and so the idea is to design a very efficient ventilation system where we use things like total heat recovery, recovering both the sensible or the dry heat and also the latent heat, the part of the heat that's humidity.
Okay.
Recovering that before and transferring from exhaust air to the intake air into your building. The other thing that I talked about before was having very efficient filtration so that you can maintain the same air quality using less ventilation air. And again, by controlling the infiltration, that means that you're not having any uncontrolled, unheated or uncooled air, any raw air come into your building. So you want to try to maintain that as well.
All right, so I want to give you a scenario. Imagine that a client comes to you and they're like, we want to build a 100-story tower and we want it to be the pinnacle of sustainability. And we want to integrate all of our systems. We want to use Passive House, everything we can. Walk me through the process that you would go through with both the engineers and the architects and whoever else might be involved in the team. What systems are you looking at and what sort of decisions would you be trying to make?
So I'm going to start very early, where the first thing we would be to sit with the owner and come up with design criteria meeting the requirements of that building.
Okay.
We'd also come up with different factors to rate the importance of different systems, factors like energy efficiency, occupant comfort, things like reliability and the hardness of systems, resiliency of systems, safety, occupant safety and health. And we give factors. How important are each of those to it? How does capital cost play in? And we balance that.
Like a weighted scale.
Yes, and it'd be a weighted scale for all these factors.
Okay.
Then we would start with talking with the architect about what his vision is and seeing where we can assist with energy analysis to get the best designed building, giving him some criteria. Where do we want sun to come into the building? Where do we want to shade it out? And start running energy analysis like we did on a couple of the projects I talked about earlier to find out what the best massing and siding, the most efficient massing and siding of the building are that does three things: reduces energy efficiency, but at the same time fulfills the architect's vision of the building, and also makes the building more functional, or as functional as it can be. And we start looking at those factors and trading off. Mm-hmm. At the same time, we start talking about what we think the proper systems are for the building to meet the owner's requirements, because those systems always have effects on the architecture. Are we going to do an underfloor air distribution system, which has a lot of indoor air quality benefits, but may change somewhat of how you're going to do your ceiling heights and sandwiches in the building, floor sandwiches?
Okay.
And start talking about all that together very early on in the process.
So from first sitting down with the owner until the beginning of construction, how long is that phase typically?
To the beginning of construction?
Yeah.
Depending on the building and the process, it's typically on a large building, it's about a year. Sometimes it's a little longer if it's a more complex building. A lot of the time right now we're fast-tracking projects and we're starting early construction like foundations while we're still designing the building. And again, which is why it's very important that you come up with all these concepts and you understand what you're doing very early on in the process.
Yeah, that definitely makes a lot of sense to me. Are there any projects you're working on currently that you're excited about you'd like to discuss?
Yeah, I have a lot of projects. I don't know. I didn't talk to any of the owners if it's okay to talk about their ongoing projects. I probably think of what I have that's really fascinating right now.
Okay.
And again, keeping in mind that for me, it's some of the things that people find interesting are sort of commonplace to me at this point. We're doing the terminal for the New York Wheel, which is the giant Ferris wheel that's being built over in Staten Island.
Okay.
And what's great about that building is there's a park on top of the building, so it's all green roof. It's going to give public use. We're using very high efficiency air conditioning equipment in it. We're using magnetic bearing chillers, which are near frictionless. And so what it does is it even if at full load it makes energy consumption much less, and it has this incredible part load efficiency because it's got basically the speed of the compressor can vary directly and get part load efficiencies that are like 30% more efficient than a standard chiller.
All right. So let's. I also want to ask you about your work as the supervisor of the Advanced Technology and Analysis Group.
Sure.
And is there anything really exciting coming out of that group? And what are you most excited about when it comes to technology?
We're doing a lot of analysis for radiant cooling projects, especially where we can tie it in with geothermal, where we can actually cut out compressor usage in the building for 70% of the cooling usage. So what that means is we're taking geothermal water from that we're cooling with the ground. We're getting with the temperature where we could run it through a radiant panel in the ceiling or a radiant floor, and actually using the radiant effect, cool or heat the space. But in the summer, we're not turning a compressor on, and in the winter, we're working very efficiently because we basically pull the heat out of the ground first before we have to continue heating the water.
Okay.
So using those two technologies in tandem, we've looked at some things I can't talk about because they're not real projects yet, but we've been looking at a net zero office building in the Mid-Atlantic region, and we're playing around with that right now and looking at combining technologies to get the most efficient space we can. So it would be radiant cooling combined with displacement ventilation for the ventilation air, and also to take care of the latent cooling, which is the removal of humidity. And on top of that, looking at doing some combined heat and power as well, having a cogen plant that produces a portion of the building's power and also gets some of their standby power for computers for their small data center that's in the building.
Wow, this is a lot. You've got a lot going on. I'm glad that you brought up the concept of net zero. It's something else I wanted to ask you about. Could you first just briefly explain it for any of our listeners who might not know?
So, and like sustainability, there's a lot of definitions for net zero.
Yeah.
But the idea behind a net zero building is, on a net basis, to produce as much energy as the building uses. It doesn't mean that you're not tied into the grid, because there'll be certain times when you may not be able to produce the energy, and other times when you'll produce excess energy.
Uh-huh.
But on a total, you're coming out even. And there's different ways it's defined. Some people look at it as net greenhouse gas, and so they're able to do that by purchasing renewable power certificates. But to me, the real true way of looking at it is on the building basis that you're producing as much energy as the building's using.
Okay, that's a pretty simple definition. It sounds like this is not taking into consideration the embodied energy of the building, though. Is that correct?
That's correct.
Okay.
And that's why I said there's a lot of different, I guess I didn't get into the different definitions, but one of the definitions looks at, as opposed to the energy at the building, looks at source energy. There's been people defining it as looking at embodied energy for the whole life cycle of the building. And so there's a lot of different ways that you can start to define net zero energy or net zero building.
I mean, I'm definitely an outsider to this, but it makes sense to me that it would take into consideration the embodied energy. Otherwise, it's only net once it's built. Right.
Well, I'm happy to get one that just takes into its operating energy, because it's a good start.
Yeah, totally.
It's a good place to be.
Mm-hmm.
And we're still not seeing a lot of that. Part of the reason becomes how do you generate the energy?
Okay.
And so it becomes, especially when you're talking about a high-rise building, you don't have a lot of surface to generate energy with photovoltaics. So you would need some sort of recovered resource to generate your energy, whether it was biogas or a digester that was digesting garbage and creating biogas. Where when you have, for instance, this net zero building that I'm looking at in the Mid-Atlantic region, it's a very large footprint building.
Okay.
But it's still an 8-story building, and even with that, I don't get enough surface area to be able to get a true net zero building. So you need to shore it up with energy from another source. Whereas if you were doing something out in the middle of a rural area, you can start putting photovoltaic panels on some of your site and be able to really make a net zero building that way. On a high rise, it's much more difficult because you don't have the area for photovoltaics. Wind turbines on a building are still not that efficient. You don't get a lot of bang for your buck, so you don't see a lot of that. When you have it, when you see it right now, it's usually more of a demonstration technology. We had a building, a tower in Florida that never got built that we were looking at. It was a 1,000-foot tall tower, and it had 2 legs. Between the legs, we were going to have wind turbines up and down the tower.
Okay.
And also on the south face, there was a big south-facing facade that swooped down, and we were going to cover about 60% of that with photovoltaics. And we were able to find through calculation with the right systems that we can get a true net zero building on that. But most of the energy was being generated by the photovoltaics. Only about 25% of the energy was coming from the wind turbines. And we looked at a lot of other different types of renewable energy generation sources. We looked at having micro hydro turbines in the rain leaders, and there was no way to get enough dependable supply out of that to really count it. We looked at putting some tidal generators out in the bay and found out it was a little difficult with the protected area in the bay that we were on to be able to do anything like that. But so we got to explore. It was a fun project. We got to explore a lot of different technologies with it. And in the end, what we found was the real, still the real way on a commercial building to generate power is through photovoltaics. If you're in an area that has a good biogas supply, that works perfect. But there's not a lot of developed biogas supply out there.
Yeah.
So it becomes, especially in major cities, so it becomes difficult.
So as far as I know, any of the net zero buildings that have been built have all been fairly small scale. Are there any larger examples out there that you're aware of?
There was one, the Pearl River project that SOM was advertising. I don't know if that ever got built and was really net zero, so I can't comment on that.
Okay.
You'd hear about that for about a period of 4 or 5 years. You heard a lot about it, and then it sort of went away. And I've designed a few urban area net zero projects, but again, they were all sort of mid-rise, 10-story, 8-story type of buildings. So I haven't seen one that's actually been built and operating that's been fulfilling the net zero claim. I've seen a lot of smaller buildings that are doing it.
Okay. Is net zero possible in these very large buildings?
Yeah, I think when we looked at the job that I was talking about in Florida, it didn't have a lot of program area. So we were really able to make that work. If you're looking at something that was, and again, if you looked at from the financial side on that, it really depended on getting a lot of funding sources from government grants, things like that. So to make it feasible, to get a building that's actually got a good return on investment on a large building, I haven't seen it yet, but we're always looking for that opportunity to get a net zero building that we can get built, and that makes sense.
Okay, great. So I want to take into consideration everything we've talked about so far and pose another question to you, which is, how does all this technology, how does using Passive House, how does striving for net zero, how does all that change when we increase the scale to something much larger, something of a vertical city scale, where we're looking at integrating multiple towers together via sky lobbies and producing something that can hold maybe 100,000 or 250,000 people? What other factors come into play?
It's a lot of the same factors, just on a larger scale. Again, the big issue is always, how do you generate enough? If you're really trying to do a net zero, how do you generate the power? But if you have a self-sufficient vertical city where you're dealing with your own sewage treatment, for instance, you could generate biogas off of that. There's a lot more when you're starting to talk about a true vertical city. You're getting a lot more opportunity out of that.
That's great. That's actually what another thing I wanted to ask you is, do you think that there are actually a lot of innate benefits to doing larger? One of the things that come to mind for me is like, you're higher in the atmosphere, so you can generate more wind power.
Correct. And again, when we did that 1,000-foot tall building in Florida, we were getting fairly decent wind generation as opposed to looking at something that was 10, 12 stories.
Sure.
Up near the top. It also at a lot of times, for the current technology, sometimes the wind speeds were getting almost too quick where we'd have to lock the turbines down.
Wow. That's interesting.
Which was very interesting. But the idea behind, if you're trying to create a self-sufficient city, there's a lot more opportunities for energy generation in that.
So you mentioned the biomass, the waste, and I mentioned the wind. What other energy opportunities are there?
Again, looking at micro hydro for if you're in an area that has a lot of rain and you've got a very tall storm leader where you're letting the water drop by gravity, collecting it in a tank up top, slowly letting it out and generating a little bit of power that way We talked about biogas, which would be good. If you're covering a lot of ground, you can start looking at things like, again, geothermal for heating and cooling to be able to reduce, because a lot of net zero is really getting your usage, your power usage, to be as little as possible. And that's one of the ways that you really so you don't have to maximize your energy production. It's critical that you minimize your usage. And again, having different uses means that there's a lot of areas that somebody might be living in at one point and working in at another point, and there's a diversity of loads.
Okay.
So I have less loading than having a standard office building. I have less loading, but still more area that I could integrate photovoltaics or wind turbine into. So by creating a true vertical city, you really maximize a lot of different ways to produce power and to reduce your usage at the same time.
It really does make sense to me, because it's kind of like your concept of looking at things from the beginning and integrating as many systems and ideas as you can, but you're just doing that on a much larger scale. You're doing that for an entire city. So it makes sense that it would become more efficient.
And it all goes down to sort of the basic concept of doing what's right for that particular building or sets of buildings that you're doing.
Mm-hmm.
Looking at it early and getting the right design.
Okay. Let me just ask quickly about microhydro. This is referring to rainwater collection primarily?
Rainwater collection, and then so basically what you would do is put these small turbines into your rainwater leaders. So you collect the water at the top, you drop it through your pipes, and while you drop it through your pipes, you've got these turbines sitting in the pipes that actually start to spin and generate water. So you need to have a large enough building that you can collect the water on a tank at the top, do it where it's financially feasible to have that, and then let it drop over time and generate. It's not going to be your primary and generate power. It wouldn't be your primary generation source, but it's an addition to everything else. And the taller that you have, the more opportunity to use gravity that you have to generate power.
It sounds like that would be beneficial, though, because you can also harvest the rainwater and use it for your other sources.
Correct. So after it got to the bottom of the stack and you collect it again in the tank, now you can feed it in for whether it's cooling tower makeup, irrigation, flushing. Mm-hmm. You could find different ways. And always the idea behind use of resources is find 3 or 4 different ways, multiple ways to run it through your building and make use of it before you dispose of it, or hopefully maybe not even dispose of it, use every piece that's embodied within it.
All right, so another question about what would it take to design a vertical city. You mentioned a year is sort of like the time frame from sitting down with the owners until you put shovels in the ground. How much longer do you think it would take to actually totally plan out something to house 100,000 people?
Wow, haven't thought about that a lot, but yeah, I think you tackle it first with a master plan phase. Okay. Where you start looking at this, and then it becomes the issue of designing individual buildings and how many different design teams and people that you put on it. But I think that master plan phase has to be really well thought out, and probably at least a year for that to really do all the studies and get it right. Mm-hmm. Because I think that's going to be the key to how good you actually make this development is by having the right plan to begin with.
Yeah, that definitely makes sense to me. All right, great. Well, we still have a little bit of time left here on this podcast, so I'd like to open it up to you and see if there's anything particular that you're excited about that you haven't had a chance to mention you'd like to bring up.
I mean, I talked a little bit about it, but the other thing that we're seeing is really important is having is basically occupant health and comfort. Mm-hmm. And that's something I've really seen take the forefront over the last several years, where corporations, like large corporations, all understand now that the most important thing in a building and their biggest cost is not the building itself, but the employees that are in their building. And anything that you can do to make them work more efficiently, and also to retain them, not have to retrain new employees, that really hits the bottom line, and that has a bigger return on investment than anything else that you can do in a building. So things like indoor air quality, even things like the quality of lighting in a space, how much natural daylight that you get, ergonomics of the design of a space, how comfortable people are, having the proper amenities for them, that's all become very important. I think a lot of people building commercial buildings are starting to realize that more and more. And then the other thing is for residential, having a healthy building, not using products that off-gas, having a more healthy environment that you live in, better air quality, better water quality. That's all become very important as well. And that's, again, we've seen air quality as a very big seller for people renting out apartments. Very big way to lease out the apartments and market them.
Yeah, and I imagine that's going to become more and more important as time goes on, especially as we still struggle with pollution issues. And oftentimes, if you're in Beijing, you can have much better air quality inside than you ever would outside.
Yes. So that's what else has really been changing a lot. There's some new certifications out there. There's well building certification that goes along with that, creating a better environment for your occupants. We've seen on the residential side something called environmental green communities that some of the developers are starting to pursue, which looks at it's a lot like LEED, but it changes the factors to be more related to residential buildings. So that's some of the other new developments that we're seeing. This LEED version 4 that I think a lot of people don't even know about yet, and having these material certifications where you look at the total embodied energy of a material and also the wellness coefficient of wellness rating of a material, how healthy is a material that you're putting in your building. That's going to be, I think, for the next years coming, that's going to be a very large transformation in the market.
All right. So for this, what did you refer to it as the wellness rating?
So one of the things that LEED looks at, that the new LEED looks at, is they look at what is going into the different materials that you're putting in your building. Do they off-gas? Are they toxic?
Okay.
How does it affect the health and well-being? How does each material you use in the building affect the health and well-being of the occupants? So what type of chemicals are in there? What type of off-gassing will occur? And that's, to me, that's one of the very big changes. And also looking at embodied energy, again, not just recycled content. If you have a high recycled content item that you had to ship halfway around the world, there's a whole embodied energy component and the amount of greenhouse gases that you're generating to transport a material, to produce a material. All of this is now starting to be looked at in the new product certifications that LEED is using.
That's great. I like the idea of measuring the wellness of a product, and I've always thought of LEED as something about energy and about becoming more energy efficient, but this is really making it about something much larger than that.
Right, and it's gone from a very simplistic view of it, which I think was necessary at the beginning, to really looking at the bigger picture for everything. Okay. And to me, it's really gone in the right way, and it's addressed a lot of the concerns that people have had about, how important are some of these credits that LEED has. Mm-hmm. The other change in LEED, and that's happened a while ago, has been the looking at greenhouse gases and sort of putting a higher weighting on credits that have effects on greenhouse gas. Okay. And reduction of greenhouse gases.
That sounds like a positive change.
That's been another good change that we've seen from the LEED system.
All right, great. Scott, I really appreciate you meeting with me. This has been a really interesting interview. Just before we sign off, what I always do with my listeners is I give them a chance, if you want to, just to give a call to action to our listeners, inspire them to do something or to check out something. And this is totally up to you, whatever you'd like to do.
Whatever I'd like to do.
Yeah.
I think, and this is really geared towards people who are designing buildings or own buildings.
Okay.
Is to employ the proper process in your design and construction of a building to get a real integrated project that all the different systems work together, and it's just you're building the right building. You're balancing all the factors and get a building that you're going to have for the future and that's going to have a good effect on the future of the world.
Sounds good. All right, Scott, thank you so much. I appreciate it. you for listening to this episode of Vertical City. Learn more about the Vertical City concept and continue the conversation by visiting our website, verticalcity.org. I truly hope that you have enjoyed this episode. If you did, please subscribe to our podcast, leave a review on iTunes, and most importantly, share Vertical City with your friends and colleagues so that together we can create solutions for sustainable living. I'm Lennon Richardson, signing off for the Vertical City team. See you next time.